Welcome to this explainer. Today we're going to completely demystify the incredible world of robot programming. If you've ever wondered how mere lines of code translate into these massive, hyper-precise physical movements on a factory floor, you are in the exact right place. Let's dive in. So here's our roadmap from concept to application. We're going to cover 1. The basics, 2. Robot components, 3. Programming mechanics, 4. Industrial applications, 5. Your future and career, and finally, 6. DEVI automation solutions.
All right, Section 1. The basics, the foundation of robotics. Grasping this technology is an absolute game changer for understanding modern manufacturing.
So, I want you to think about this for a second. Why is robot programming such a critical skill right now? Well, it really comes down to the pressing industrial need for 3 things: speed, safety, and absolute precision. I mean, human hands are amazing, right? But we get tired, we make errors, we need breaks. In high-stakes manufacturing, automation takes over those dull, dirty, and dangerous tasks, and it works continuously with pinpoint accuracy. That right there is the basic working principle of modern automation.
Now, what actually separates an industrial robot from, say, your everyday household appliance? It comes down to 3 key traits. First, it's automatically controlled, meaning once it's set, it just runs on its own. Second, it's reprogrammable and multi-purpose. So unlike a simple machine that's built to just do one thing forever, a robot can weld cars today and then be completely reprogrammed to package boxes tomorrow. And third, it operates across multiple physical axes, which gives it just incredible flexibility.
So now that we know what they are, let's look at what they're actually made of. Section 2. Robot components, the anatomy.
Honestly, the best way to understand the anatomy of an industrial robot is just to compare it to the human body. Think of it like this. The controller is the brain. It processes our code and directs all the actions. The mechanical arm is just like your arm and hand, giving it that physical reach. Sensors, those are the eyes and skin, constantly gathering real-time data about the environment. Then you have the end effector, which could be a gripper or maybe a welding torch, and that acts like your fingers, interacting directly with the object. And the servo motors, those are literally the muscles powering every single movement. Oh, and beyond this, there are 2 other vital pieces you should know about. The teach pendant, which is basically the interface we use to teach the brain, and the safety system, which acts kind of like the robot's instinct for self-preservation, making absolutely sure it stops if a human gets too close.
All right, we've got the physical components. But how do we actually communicate with them? Let's get into Section 3, Programming Mechanics, Communicating with Code.
Understanding how we tell a robot to move is absolutely crucial, and there are basically 2 main ways to do it. First, point-to-point, or PTP. This is exactly what it sounds like. You just tell the robot, hey, go from point A to point B. The exact path it takes to get there doesn't really matter all that much, as long as it gets there fast and doesn't hit anything. It's super great for moving objects. But then you have continuous path programming. This is for when the exact fluid trajectory is vital. Think of a robot painting a car door or doing a really complex weld. Every single millimeter of that journey has to be strictly controlled by the code.
To pull off these moves, robots navigate a 3D space using your standard X, Y, and Z coordinates. They can use joint movement, where individual joints rotate to reach a position, or linear movement, where the tool moves in a perfectly straight line. But here is the really fascinating part. You don't always program the physical robot right there on the factory floor. We use offline programming and simulation software. This is a total game changer. It allows programmers to write and test the code perfectly in a virtual 3D environment first. I mean, you can crash a million virtual robots while perfecting your code, saving massive amounts of time, money, and hardware before you ever even touch the physical machine.
A robot is never an isolated island on a factory floor. It has to talk to the rest of the factory. Step 1 here is integrating it with the PLC, the Programmable Logic Controller. You can think of that as the main computer controlling the entire assembly line. Step 2 is HMI, the Human-Machine Interface, and SCADA Communication, which stands for Supervisory Control and Data Acquisition. That's a mouthful, but basically it allows human operators to monitor the robot's performance on screens and gather critical data. And finally, Step 3 involves integrating vision systems. This is literally giving the robot camera eyes, so it can adapt on the fly. Imagine it tracking and picking up a randomly placed part right off a moving conveyor belt. Pretty cool, right?
Okay, now that we understand the mechanics and the integration, let's see what this looks like out there in the real world. Section 4. Industrial Applications. Robots in the real world.
The versatility of properly programmed robots is just absolutely staggering. For instance, in automotive plants, you have welding and painting robots executing those flawless continuous path routines we talked about. Over in logistics, high-speed pick-and-place robots are rapidly sorting items, while these massive, heavy-duty arms handle packaging and palletizing huge loads. In machining, robots perfectly load and unload metal parts into CNC machines, which keeps production running 24/7. And all of this, it culminates in total assembly line automation, where multiple robots work together in perfect, choreographed harmony.
And this all points directly to the future. Like the quote says, the integration of AI and industrial IoT is turning traditional setups into smart factories. With the rise of Industry 4.0, we aren't just writing static code anymore. By linking these robots up with artificial intelligence and the Industrial Internet of Things, or IoT, these machines can now predict when they need maintenance, optimize their own paths, and literally learn from their mistakes. They're transforming those old traditional rigid assembly lines into incredibly adaptive, highly intelligent smart factories.
Moving right along to Section 5, Future and Career, Building Your Path. With all this incredible technology we've covered, what does this actually mean for you personally?
Well, like any complex field, we have to look at it objectively. The pros of robot programming are undeniable. We're talking massive leaps in efficiency, unmatched speed, and keeping human workers way out of dangerous environments. But it does come with real-world challenges for sure. Robots require meticulous maintenance. Programmers are constantly facing complex troubleshooting, dealing with software errors, hardware faults, and strictly managing safety protocols to make absolutely sure human workers aren't put at risk by all this heavy moving machinery.
So, if you want to build a career in this rapidly evolving field, here's an actionable roadmap for you. First, learn the core basics, which is exactly what we're doing right here in this explainer. Second, master the specific software and programming languages used by the major robot manufacturers. Third, don't just learn the robot itself, understand the integration. You need to know how those PLCs and sensors connect to the broader system. And finally, prepare for technical interviews. Be ready to explain your troubleshooting logic, exactly how you'd handle common errors, and your absolute, non-negotiable commitment to safety protocols.
Now, if you're looking to master these skills yourself or maybe implement them in your business, you really need a premier partner. So Section 6, DEVI Automation Solutions, your industry partner. Let's take a look at DEVI Automation Solutions. Their entire focus is built right on this idea. Smart technology, powerful solutions, better tomorrow. They're a highly trusted provider standing right at the forefront of modern industrial solutions. They offer both robust implementation services and some truly expert training for the next generation of engineers.
And DEVI Automation Solutions doesn't just stop at robotics. They actually cover the entire spectrum of cutting-edge tech. They provide comprehensive industrial automation services, which includes those exact PLC, HMI, and SCADA systems we were discussing earlier. They're also pioneering integration with artificial intelligence and IIoT. And remarkably, their expertise even extends way beyond the factory floor into really specialized sectors like smart agriculture, home automation, and sustainable solar solutions.
So, as we wrap up, the crucial point to take away from our time together today is this entire journey. We've seen how understanding the physical components of a robot links directly to how we program its mechanics. We saw how those programming techniques breathe actual life into real-world factory applications. And most importantly, we mapped out exactly how you can turn this knowledge into a powerful, future-proof career path.
I want to leave you with this final thought. Are you ready to step into the future of automation? Because honestly, the future's already here, and it is moving fast. If you're looking for consulting, industry-leading services, or top-tier training to really elevate your career, I highly encourage you to reach out directly at dvautomationsolutions@gmail.com. Thank you so much for joining me in this explainer. If you found this breakdown valuable, please hit like, share, and subscribe so we can keep bringing you the concepts that are building our tomorrow. See you next time.